Hello students, welcome to Tuteetute. So in our questions, we'll see the next set of questions from this 500 questions. Okay, so two bulbs of 100 watt by 250 volts and 150 watt by 250 volt are connected in series across a supply of 250 volt. The power consumed by the circuit is, okay, so they are asking. So they have connected two bulbs, okay, so this is one bulb and this is another bulb like this in series, and they have connected so across a source, okay, so some voltage source they have mentioned, so which is having certain value of 250 volts. Okay, so question, whenever you see the question, you need to read only once, okay, so not many times. So two bulbs of 100 watts by 250 volt, like that one by one again if you read, you will waste the time. Okay, so anyway, so this is 100 watt by, so voltage rating is 250 volt. Okay, so this one 150 watt by 250 volt, so they have mentioned like this. So they are asking about the power consumption in this network. Okay, so that means if you know about the current in this network, so directly we can calculate. Okay, 250 into that current will be our power. Okay, so otherwise if you know the resistances of these two, so then again, okay, so V square divided by that resistance will give the value. Okay, so combined resistance, otherwise current or resistance, any one thing. So for the first bulb, if you check, okay, so voltage rating is 250 volt and power rating is 100 watt. If you want to calculate the resistance, R equals to, so V square divided by P. Okay, so 250 into 250 into 250 divided by P is 100. Okay, so anyway 25 into 25, 625 watts we are getting. Okay, 625 ohms. Okay, so not watts, 625 ohms we are getting. Okay, so this is R1. Okay, similar to this R2. What is R2? R2 equals to, so 250 square divided by 150. Okay, so 250 into 250 divided by 150. Okay, so 53s and 55s. Okay, so 53s and 55s you will be getting, so 1250 divided by 3. Okay, so this is the R2 in terms of ohms. Okay, so these are the two resistances. So this is 1250, so this is 625 and this is 1250 divided by 3. So if you check the complete resistance R1 plus R2, so then you will get the complete resistance of this network or this circuit. Okay, so then you will be getting 625, okay, plus 1250 divided by 3. Okay, so 625 2 times if you take, okay, so then you will be getting, so this 625 you can write down as 1250 divided by 2 you can write down. Okay, so anyhow if you take the LCM you will be getting 6 and you need to multiply this one with 3. Okay, so then you will be getting, so 3750 plus 1250 into 2 is, so 2500. Okay, so this is the complete one. So anyhow, okay, so 3750 plus 2500 you will be getting 5000 and 6250. Okay, 6250 divided by 6 you will be getting. Okay, so this is the complete resistance. What they are asking about the, so power. Okay, so power means this is the voltage source, this entire resistance we have got already. So this is in terms of ohms. Then so the power consumption in the network we can give it as again V square by R. Okay, so V square by R means 250 into 250. Okay, so here we can get 250 into 250 divided by, so this resistance. Okay, so this resistance is 6250 divided by 6 you will be getting. Okay, so anyhow, so 0 and 0 will be cancelled, 25 into 25 is 625 will be cancelled, and in the numerator we will be having only 10 by 6 you will be having. Okay, okay, so 10 here and 6 we have. Okay, so then you will be getting 60 watts. So this is the answer for this question. Okay, 60 watts will be the answer for this. 10 into 6. Okay, so that's why 60 watts. Okay, so this is the answer for this question. Okay, so anyway simple calculations only, so if you do within 1 minute it will be more comfortable. Okay, so the next question, current having waveform shown is following in a resistance of 10 ohms. Okay, so the average power is, okay, so waveform they have mentioned and they are asking about average power. Okay, so P is always, power is always average only. Okay, so power is always average only, so that we can give it as current waveform they have given I RMS square into R. Like this we have to calculate. Okay. So what is RMS value of this one? This is a triangular waveform or sawtooth waveform. Okay. For the triangular waveform or for the sawtooth waveform. Okay. So average value of this waveform is equals to maximum value divided by 2. Okay. So this is the average value. RMS value, anything, either current or voltage or any waveform it is. Okay. So RMS value equals to maximum value divided by root 3. Okay, so remember these two. So definitely this model of problems many times they have given in our exam also. Okay, so anyhow, so answer now it will be RMS value, that means maximum value is 10 divided by root 3 whole square into R. Okay, so R value is 10 ohms. Okay, so 10 ohms. So you will be getting as 100 divided by 3 into 10, that will be equals to 1000 by 3 watts. Okay, so you will be getting 1000 by 3 watts. Okay, that's the answer for this. Okay, remember with the waveforms. Okay, so whatever waveforms, sine waveform, okay, so then square waveform, okay, so then DC waveform, okay, so DC waveform, okay, so and similarly so triangular waveform. Okay, so triangular waveform, for all these waveforms, so we need to get the average value. Okay, so RMS value. Okay, so then so you have to calculate the form factor. Okay, so then peak value, peak factor. Okay, so peak value and peak factor. Okay, so both you have to know. Okay, so if you know about these things, okay, so then we can expect mostly this kind of question. Okay, so because some questions they will give as simple only. Okay, that's why this model of questions, if you know about all these waveforms, okay, and their values. Okay, so in sinusoidal waveform also, so sinusoidal waveform normal, then so half wave rectified. Okay, so half wave rectified waveform and full wave rectified waveform. Okay, so anyhow in power electronics you will be learning if you are electrical, otherwise in analog electronics also you will be learning this one. So in the so other chapters like diode circuits also. Okay, so anyhow, so the rectifiers concept we need to understand, then you will know the average and RMS values of these waveforms also. Okay, so these are all important things. Okay, so next one, two coupled coils connected in series have an equivalent inductance of 16 millihenry or 8 millihenry depending on the interconnection. Okay, so then the mutual inductance M between the coils is. Okay, see directly we need to answer, but see whenever you read the question, okay, so whenever you read the question, immediately you need to get the point in that. Okay, so that means this kind of question you should have practiced before, then whenever you see, okay, so you will not get confused, immediately you will answer. Okay, see what they have given, two coupled coils connected in series. So coupled coils they have mentioned the equivalent inductance of sometimes 16. Okay, so sometimes 16 millihenry we are getting and 8 millihenry they are getting. Okay, so this is interconnection, depending upon their interconnection they are connected in series. Okay, so two coupled coils they have mentioned. If so both are connected in series aiding. Okay, so we have seen in the other session, so then L1 plus L2 plus 2M. Okay, so this is the one connection, and another connection L1 plus L2 minus 2M. So this is the another connection. Okay, this is aiding. Okay, so this is aiding, this is opposing. Okay, so I have given so opposing. Okay, so I have given, so even for the parallel interconnection also. Okay, for the coupled circuits, so this is even old problem, but till now also. Okay, so they are giving this model of questions. Okay, so this is engineering services question, but now also this kind of questions are possible. Okay, so they have mentioned in some case we are getting 16 millihenry, in some case we are getting 8 millihenry. Add these two, whenever you add these two, so these two not add, subtraction. Okay, so subtraction if you do, then you will be getting 4M equals to, so subtraction means 8 you will get. Okay, so that means mutual inductance you will be getting as 2 millihenry. How it is millihenry? Because other things also are in millihenry, that's why 2 millihenry we will be getting. Okay, so next question. So the equivalent resistance between the terminal points X and Y of the circuit shown is. Okay, so last time I have uploaded the bridge circuit. Okay, so directly whenever you see this question there you may confuse. Okay, so it may be star connection, delta connection, all these things, nothing to worry. So see the arms. Okay, so here 15 plus 15 30 is there, 15 plus 15 30 is there, so 30 30 30 and 30. Okay, so it is just like this is X and this is Y and here we have 30, here we have 30 ohms, and here also we have 30 ohms, and here also we have 30 ohms, like this. Okay, so forget about all this. Okay, so you no need to draw. Okay, directly 30 into 30 equal to 30 into 30, you know, bits is getting balanced, so these two are connected in series. No current will flow in the middle. Okay, so I equals to 0 means it will act like open circuit. 30 in series with 30, 60, in parallel with other side also 30 in series with 30, 60, you will be getting as 30 ohms. Okay, so don't ask how you are getting 30. So whenever two resistances of same values are connected in series, then you will be getting so half of that value. Okay, so 30 ohms will be the answer for this. Okay, so next question, the value of current I flowing in the 1 ohm resistor in the circuit shown will be. Okay, so this is a very important question. So there are engineering services questions, so this is one of the GENCO question also previously. Okay, so in 2012 I think they have asked this question. So resistor, they have mentioned current in that resistance. Okay, so directly within fraction of seconds, voltage between these two is 5 volt, so you will be getting 5 amperes of current here. Okay, so no problem, answer is 5 amperes. We can go to next question. Okay, but so we need, this kind of questions are already over. Okay, important model only, so this kind of questions are already over. So what they may give now from this question? Okay, so now the extension of this question is the current they will only give. Okay, so the resistance. Okay, so otherwise the current flowing in the 1 ohm resistor is 5 amperes. What is the contribution of 5 volt source and what is the contribution of 5 ampere source? They will ask like that. Okay, so then what you have to do, so you need to apply the superposition. If only 5 volt source is present, see this kind of question they have not asked yet. Okay, if they give in this next time, okay, so you need to give credit definitely to me. Okay, so I have never seen this model of question, only in my mind it is there now. Okay, so only 5 volt source is connected, so then the current source we have to open circuit, because internal resistance of this one is infinity ohms, internal resistance. Okay, so why internal resistance? So whenever you are activating this source, other sources we need to deactivate. So if any resistance is present for this, we need to represent with that. Internal resistance of current source is infinity ohms. That's why infinity ohms means open circuit. So current source we have open circuited. Okay, so here we have 1 ohm of resistance, directly 5 volt, and here we are getting 5 amperes of current. Okay, so because of 5 volt you are getting 5 amperes of current. Okay, so I1 current we got as 5 ampere. I1 means in first case. Okay, so similarly, so current source we have activated. Then voltage source, what is the internal resistance of voltage source? It is 0 ohms, so that means short circuit. Okay, so we have to deactivate this source means, so then short circuit we have to replace. Okay, so current sources to be open circuited, voltage sources to be short circuited. Why we have these concepts? Because internal resistances are there. Okay, so and here 5 amperes current source is there, and here we have the resistance of 1 ohm. Here we need the current I. Okay, so in this case it is I2. Okay, because second case. Okay, so here 5 amperes current is coming up to here. It has seen one of the short circuit. Okay, so everything is getting shorted and no current will go like this. So because of the current source, I2 equals to 0. Okay, so I1 equal to 5 ampere, I2 equal to 0. So total I equals to I1 plus I2. Who told this one? Superposition theorem. Okay, so algebra superposition theorem means, so the total response is equals to sum of the individual responses. Okay, for the voltage and currents only it will be suitable. Okay, so I equals to 5 plus 0 equals to 5 amperes. Okay, so this is the answer directly. Okay, we know already 5 amperes. Okay, so this is the correct answer. Here one more point also we need to get. Okay, whenever a voltage source and current source are connected in parallel. Okay, so forget about values. Okay, so forget about values. So it may be 5 volt and 5 amperes. Okay, so whenever two sources, okay, so one current source and one voltage source, so which are connected in parallel, which will be dominating means the voltage source will dominate. Okay, so we need to understand that. We can connect like this, there is no problem. Voltage source will be dominating in performance. Okay, so like most of the power will be given by only this one. Okay, so like across how many elements are there, so based on that directly voltage source will be active. Okay, similar to this. Okay, so whenever a current source in series with voltage source, then which is dominant means the current source will be dominant. Okay, so like that we need to understand. Okay, see from this kind of question we can get so much of analysis. Okay, so that's why, so when previous year questions we need to solve more. Okay, next question, in the circuit shown, which of the following statement is not correct? Okay, so not correct they are asking. The circuit has a super mesh. What is super mesh? Okay, super mesh. So this is the first mesh, this is the second mesh. See, if I want to write the mesh equation of this one, okay, so first mesh equation if I try to write, so it will be, I have seen minus, okay, so minus 20, okay, so plus 6 into I1, okay, so I1, okay, 6 into I1 plus 2 into I1 in this direction, I2 in this direction, so I1 minus I2. So after that, I need to represent the voltage, right? This is KVL equation, okay? So I need to represent the voltage means in a current source we don't know voltage. How to represent now? We cannot represent here. That's why writing the mesh equation or writing the KVL equation in the first mesh is very difficult. We can't write this one, okay? Similar to that, even if you try to write in this also, we cannot write, okay? So that's why what happened. So we need to find certain solution for this one, okay? So how we need to find out? A complete mesh equation, okay, so our loop equation we have to write for this one, okay. So what is that equation? Minus 20 plus 6 I1 plus 10 I2 plus 4 I2 equals to 0, okay. So like this, y equals to 0, this is KVL, don't tell that is a mesh, okay. So algebraic sum of the voltages in a closed loop equals to 0, that means it's a KVL, okay. So this is the equation we have. So then minus 20 plus 6i plus 14i2 equals to 0. This is one equation, okay. So minus 20i minus 20 plus 6i plus 14i2 equals to 0. So this option is correct only, okay. So then again they are asking, so this is the, so I2 equals to I1 plus 6, okay. So what they have given, see, current is in this direction, I1 it is, okay. So current is in this direction, I1, I2 is in this direction, okay. So then what is this 6 amperes? 6 amperes equals to means, okay, so I2 minus I1, because I2 is supporting this, I1 is against this, I2 minus I1 equals to 6, otherwise I2 equals to 6 plus I1, okay. So this is also correct only, okay. So then another one, what is the correct one? The circuit has a super mesh, okay. Super mesh, it is correct. That's why we cannot write down the equation of single mesh. So complete mesh, this mesh equation is called super mesh equation, okay. So this is only super mesh equation, okay. Super mesh equation it is. And one more thing, okay, so why we have this super mesh problem, why we cannot write down this equation means, so between two meshes, see, remember what is super mesh means, between two meshes we have a current source, that's why this problem came, okay. So whenever current source is present between two mesh, we need to consider, okay, so we need to consider, so that it has a super mesh problem, okay. So directly we need to do like that, okay. Similarly, super node, what is super node, okay. So actually for super node there are so many analysis, okay. So I will do it in a super node, okay. So super node, so I will do in a separate video, so for super node, okay. So because we need to understand some more concept also from the super node, okay. So anyhow, answer for this question is the circuit has a super mesh, that's it, okay. So answer, this one is a wrong one, okay. So minus 20 plus 6i plus 2i, okay, so plus 2i1, okay. So this 8i1 it will become, so it is wrong only, okay. So option D is the correct one now. Correct one means which is not correct they are asking, okay. So the next question, so in the circuit shown, the voltage across 4 ohm resistor V can be expressed as, okay. So voltage across 4 ohm resistor they are asking. So and you know, okay, so there is a current I, okay, so there is a current I, so that current I will be coming like this, okay, coming like this. After coming here it may split, okay. So but what they are asking, so we need to find out the, so voltage V, okay. So voltage V means, so the current in this one we can give it as V divided by 4. Understanding? V divided by 4 will be the, so voltage current in this one. So the total current will be here is I amperes plus V by 4, okay. So like that it will be, okay. So this current and this current, okay. So now we need to write down this equation, you will get the answer, okay. So this is minus and this is plus, so minus E, okay, so plus 6 into, what is the current? I plus V by 4, okay. So I plus V by 4, okay. So plus V equals to 0. Okay, so voltage across this is V only. Okay, so they are asking about this V only. Okay, so we can simplify this one, minus C plus minus C plus, so you will be getting 6 by 4 into I plus, not this one. Okay, so 6I. Okay, 6I plus 6 by 4 into V plus V equals to 0. Okay, so we need a V value. 6 by 4 6 by 4 V plus V, you will be getting 10 by 4. Okay, so 10 by 4 V is equals to E plus 6I. Okay, so like that you will be getting. So anyhow they are asking about this 0.4. okay, every option is like that. So based on that, so this entire thing, okay, so I will be sending other side. Then 4 by 10 is nothing but 0.4 into E plus 6I. okay, so then you will be getting as V equals to 0.4 E plus, so it will be 2.4. okay, so 2.4 I. okay, so this is the answer. V equals to 0.4 E plus 2.4 I. 0.4 E plus 2.4 I. okay, so option D is the correct answer for this. Okay, so the next question, in the delta equivalent of the given star connected circuit, so ZQR is equals to, see, ZQR they are asking us. ZQR means between these two whatever resistance is coming, that they are asking. Okay, so anyhow directly we have to do 10 into J10 plus J10 into 5 plus 5 into 10. Okay, so 10 into J10 is nothing but J100 plus J10 into, so 5 we will be getting J50 plus 10 into 5 we will be getting as 50. okay, so numerator is confirmed. Then so denominator, you want impedance here, so opposite one you have to give. Okay, so divided by 5. okay, so this is the complete one. okay, so anyhow if you simplify this one, then you will be getting as 50 plus J150 divided by 5. okay, so then 10 plus J, so what you will be getting 50. okay, so 10 plus J, okay, so it is 30. okay, so it is 30. okay, so 5 3s it will be 30. okay, so 10 plus J 30. So actually I did the wrong calculation by seeing the option, so I have just to confirm again. okay, so 10 plus J 30. okay, so if 10 plus J50 is there, okay, I will choose that option only. This kind of mistakes also possible. okay, so anyhow these are the questions up to this now. okay, in our next session we'll come with the another subject, maybe power systems, otherwise measurements. So and soon we will be uploading almost all the 500 models of questions. okay, so anyway, all the best. Thank you so much.